Hey guys, welcome again. So we would be talking about how to initialize a new cluster in this lecture. So initializing a new Kubernetes cluster with the kubeadm is as simple as typing kubeadm init. As you can see where I'm pointing through my mouse cursor, the command pulls all required images and creates all the required system pods, etc. The output of the command gives you a few more commands that you need to run to set your local environment. It also gives you the kubeadm join command and token required to add additional nodes. So congratulations, that's brand new Kubernetes cluster created comprising a single master. Complete the process by running the command listed in the output of the kubeadm init command shown above. These commands may be different or even no longer required in the future. However, they copy the Kubernetes config file from /etc/kubernetes into your home directory. Change the ownership to you and export an environment variable that tells Kubernetes where to find its config. In the real world, you may want to make the environment variable a permanent part of your shell profile. Now use the kubect1 command to verify that the cluster initialized successfully, as you can see here. Okay, so run the following kubect1 command to find the reason why the cluster status is showing as not ready. As you can see here, this command shows all pods in all namespaces. This includes system pods in the system kube system namespace. As we can see, none of the kube DNS pods are running. This is because we haven't created a pod network yet. Create a pod network. The example below creates a multi-host overlay network provided by Weaveworks. However, other options exist and you do not have to go with the example shown here though. As you can see, this is the example I'm talking about. Be sure to use the right version of the Weaveworks config file. Kubernetes v1.6.0 introduced some significant changes in this area, meaning the older config files will not work with Kubernetes 1.6 and higher. Now check if the cluster status has changed from not ready to ready, which I have done it here. So the cluster is now ready and the DNS pods will now be running. Now that the cluster is up and running, it's time to add some nodes. To do this, we need this cluster join token. You might remember that this was provided as part of the output when the cluster was first initialized in the previous lecture. Scroll back up to that output, copy the kubeadm join command to the clipboard and then run it on node 2 and node 3. One point to note is the following must be performed on node 2 and node 3, and you must have already installed the prereqs, which is Docker, kubeadm, kubectl, kubelet and CNI on these nodes. So quickly I'm moving, now when we repeat the command on node 3, after making sure that the node successfully registered by running another kubect1 get nodes on the master, we get this, as you can see on the screen. So you have manually built a 3-node cluster using kubeadm, but remember that it's running a single master without HA. Now quickly we would just summarize what we have done in the couple of few chapters. In this chapter we learned how to install Kubernetes in various ways and on various platforms. We learned how to use Minikube to quickly spin up a development environment on your Mac or Windows laptop. We learned how to spin up a managed Kubernetes cluster in the Google Cloud using Google Container Engine, which is GKE. Then we looked at how to use the kops tool to spin up a cluster in AWS using the AWS provider. Here we wrapped up the chapter or lecture seeing how to perform a manual install using the kubeadm tool. There are obviously other ways and places we can install Kubernetes, but we have to restrict to cover the entire course. So I'm just keeping this limited to it. So thank you very much. In the next lecture, we would be discussing a few more interesting concepts and facts. Thank you very much.